Warm welcome to all of you. Let us begin with the first chapter of your syllabus, that is units and measurements. As you know that physics is a science which deals with the accurate knowledge about the things for which measurement is required. All those quantities which can be measured directly or indirectly can be expressed as physical quantities, for example, length, mass, temperature, etc. Now, when you measure, then measurement means the process of comparing the quantity with the standard amount of the physical quantity of the same kind. To express the measurement, we need two things: the unit in which the quantity is measured and the numerical value or the magnitude of the quantity. So the measurement of a physical quantity is the product of the numerical value and the unit. The units that are used for the measurement of the physical quantities should have the following characteristics. They should be well defined, should be of convenient size, should not change with time and temperature, easily reproducible, internationally acceptable, and easily accessible. The physical quantities can be of two types: fundamental physical quantities and the derived quantities. The physical quantity which does not require any other physical quantity to express it, or which can neither be derived from one another nor they can be resolved into anything simpler, are known as the fundamental units. The fundamental units are also known as the base units. There are different sets of units which can be used, like the CGS system, FPS, MKS, and the SI unit for the measurement of these physical quantities. The SI system, or the International System of Units, is the modernized and extended form of the metric systems like the CGS and the MKS system. It covers all the branches of science and technology. The table here shows the basic SI quantities, which are 7, their symbols, the SI units, and their definitions. The basic 7 fundamental quantities are length, the SI unit is meter; mass, kilogram; time, second; electric current, ampere; temperature, Kelvin; amount of substance, mole; luminous intensity, candela. The definitions of these physical quantities is also mentioned here. Besides this, there are two other supplementary SI units, which are plane angle and solid angle. The SI unit of plane angle is radian and solid angle is ster-radian. Besides the SI, MKS, and the CGS system, the FPS system, that is foot, pound, and second system that we have mentioned, it is not a metric system and it is not in much use nowadays. Besides that, there are other important units of length. For example, for measuring the large distances, there is astronomical unit, light year, and parsec. Some smaller distances are measured in terms of Fermi. One Fermi is normally the size of nucleus, which is 10 to the power minus 15 meters; angstrom minus 10 meters; nanometer minus 9 meters, and other conversions which can be done. Derived physical quantity and their units. All those physical quantities which can be expressed in terms of fundamental quantities, or which is a combination of two or more physical quantities, are known as derived physical quantities, and their units, which are expressed in terms of fundamental units, are known as the derived units. A very simple example is that of velocity, which is distance upon time, so the derived unit is meter per second. Similarly, density is mass upon volume, which is kg per meter cube, And force is mass into acceleration. The derived unit is kg meter per second square. These are some of the examples of derived units. These are the derived units of some other physical quantities mentioned in the table here: area, volume, frequency, density, acceleration, force, stress. There are some terms that you've already studied in your previous classes and some that you'll be studying. Like pressure and stress have the same units, which is force upon area, and it is Newton per meter square, which can be also expressed in terms of the SI units. When the magnitude of the physical quantities are very large or very small, it is convenient to express them in multiples or submultiples of the SI unit. The various prefixes used for the powers of 10 are mentioned here, like deca, hecto, kilo. These are the multipliers, and the submultipliers are deci, centi, milli, micro, nano, pico, fermo. These all can be used with the units, and the conversions should be known. That was all for today. Thank you. Have a great day.